Hello. In this video, we're going to go through a method of substitution, which is a method used for solving systems of equations. So we know that there are three methods to solve systems of equations. One is graphing, one is substitution, and one is elimination. There's no right method. In fact, the method choice is really dependent on the person doing the math. However, often one method is faster or easier than other methods. I do caution students around using graphing all the time because eventually you get to the point where you won't be able to graph these nicely and find the solution. So remember, we start learning this idea of systems of equations with linear relationships. And we know that the solution to a system is where two lines intersect. But an important thing to kind of start to think about is that we're using linear relationships because we can visualize them. But the techniques we're learning apply to nonlinear systems as well. And I really like to remind students not to be intimidated if they see a system that has something other than a linear relationship in it, because chances are you can apply the same tools you've learned and be successful. So let's dive in, shall we? We're going to solve this system with substitution. Now on the surface, it might look like elimination is a better choice, and it would work very well because we see that our x components, our y components, and our constant components are lined up. But what I really like about this problem is the fact that y has no coefficient, so it makes it very easy to rearrange and isolate for y and substitute in. So when you're going through the process of solving a system of equations, always number the equations because it helps with communication. So the first thing I'm going to do is I'm going to take equation 2 and I'm going to rearrange so that we get y equals. So we have 5x minus y equals negative 15. So when I rearrange this, I'm going to get y is equal to 5x plus 15. And I'm going to call this equation star. You could call this equation 3. Doesn't matter. So now, the reason why this is called substitution is because I substitute directly into the other equation. So we're going to sub star into 1. And what I'm going to get is 2x plus 3, and don't forget the brackets here, 5x plus 15. This is where students often make a mistake. And what that mistake is they'll forget that 3 applies to both terms that is being both terms that are substituted in. So now if we rearrange 2x plus 15x plus 45 equals 11, 17x plus 45 equals 11, 17x is equal to minus 34, divide one side by 17, divide the other side by 17, and remember, I'm showing a number of steps here to help communicate how I do this, but really, you can find the right number of steps for you. We do recommend, though, that when you're communicating your information on a test or something like that, the more steps you show, the easier it is for the teacher to find where you might have made a mistake if you happen to do that. So it's always finding that balance. So x is equal to minus 2. So therefore, if x is equal to minus 2, we sub x equals minus 2 into any of the original equations. So let's sub x equals minus 2 into equation 2. So we're going to get 5 times minus 2 minus y equals minus 15. So now I get minus 10 minus y is equal to minus 15. So we get y is equal to minus 10 plus 15. So y is equal to 5. Therefore, the solution is minus 2, 5. And I always like to encourage students to take their final answer and put a box around it. Now, a step that's important when you're working with the systems of equations is your check. It's always good to do a check at the end to make sure that you're right. So we check simply by substituting our value into one of our equations. You really could substitute into both, and that's probably, if you want to be really thorough, it's a good thing to do, but I'm quite happy with one equation. So let's sub it into equation 1. So we have 2 times minus 2 plus 3 times 5 equals 11. So minus 4 plus 15 equals 11. And what a lot of students do here is they stop, because we can see that this works now. But remember, you're communicating your answer to someone. So take it that last step, 11 equals 11. And just to make sure we show that the left side is equal to the right side. I hope that video helped.